Hi, I'm Kat Beheshti, and I'm an assistant researcher with the University of California, Santa Barbara.
Hi, I'm Melissa. I am a research scientist here in San Diego.
Today we are in San Diego Lagoon, where eelgrass restoration was conducted as part of a mitigation project.
So there are multiple things a restoration practitioner should consider before they're ready to actually put plants in the ground. Those steps can be summarized into 5 key components. So the first being to assess your site's suitability, so select a good restoration site. The second is to select your restoration methods. The third is to conduct a pilot restoration project. The fourth is to conduct your restoration project at scale. And then lastly, to monitor your restoration efforts. So we'll go into those a little bit more in detail in this video, but there's also a report out written by myself and Dr. Kat Beheshti, which you can read about if you want more detail.
Selecting a site is essential. There's a lot of evidence to suggest that the characteristics of a particular site are what can often drive failure of a restoration project to meet its expected goals or outcomes. And so rather than considering above all else transplant method, you need to first consider, is this a suitable site for eelgrass restoration? A good question that all practitioners should ask first is, why is there not seagrass here now? And if you have access to historical maps and you see that there was historically eelgrass at a place that you're considering, then you should ask, why is eelgrass not there now? If, for example, the sediment environment is not conducive to eelgrass restoration, then you might need to improve those conditions. For example, removing debris or derelict gear. Or if a site was too shallow to support eelgrass and has undergone some erosion and is now at a suitable depth to support eelgrass, then maybe the only reason it isn't present is because it's too far away from a source population, in which case your efforts to transplant would be very valuable.
There are numerous restoration methods that could be used for your particular project. It's important to understand your own project's limitations or constraints when choosing your restoration method. The method-specific videos walk through many of these specific considerations. Linked in the video description is a detailed handbook specific to the garden staple method, as well as an eelgrass restoration synthesis led by Dr. Melissa Ward and myself, which outlines the primary pros and cons for the most commonly used approaches. In the synthesis report, we have a figure shown here that walks the reader through the advantages and disadvantages of these main methods. If we zoom in here on the popsicle stick method, you'll notice that one of the advantages of this method is that it's low cost. Another few set of advantages are that it's made of biodegradable material, requires moderate preparation time, is effective in low flow environments, compatible with intertidal planting, which also makes it a perfect method for engaging with citizen scientists. And this planting method is moderately fast compared to other reviewed methods in this table. Now, a few of the disadvantages of this method is that deeper restorations require scuba diver support, and it's challenging to relocate plots should the seagrass fail to persist post-transplanting. So this is just one example of the many methods reviewed in the eelgrass synthesis report, which will be linked in the video description below. Another important factor to consider is how long it will take to acquire the proper permits. And so any project that's about to take place needs to make sure that they have the proper permissions and permits in hand for their restoration project. And these are permits that are often issued by agencies like the Department of Fish and Wildlife.
In a perfect world, a regionally specific habitat site suitability model would be used to identify good candidate restoration sites, and those models use inputs like depth and light availability to evaluate what places within your site or bay are going to be promising for restoration success. However, if you don't have a site suitability model available to you, what you can do is use those same types of principles with certain information available to you on environmental conditions to identify good candidate restoration sites. So one thing you should take care to do is take a close look at the eelgrass already growing within your system and try to find a site that looks similar such that it could support populations of eelgrass. It just hasn't yet colonized that area. So of course, light availability and depth are both very important, and you need to take those to consideration in your site. So if you want to plant a half-acre meadow, but you have a very steep depth gradient in your bay, you might end up with this sort of bathtub ring style of eelgrass, and you want to find a site that has a longer, flatter, shallow zone that you could transplant into. It also goes without saying that there are certain logistical constraints that your project might have. So for example, perhaps the site that you've identified as your best candidate restoration site is particularly far away or deep, in which case you might need a boat to access the site, or you might need to be on scuba, both of which can change the project costs or the skills that the personnel need to conduct the work. So once you've identified what sites you think would be good for restoration, it's best to go out to those sites in person so you can make sure that there's nothing unusual about the site that might make it unsuitable for restoration.
Practitioners must also have a plan for how they're going to harvest the shoots for transplanting. So there's mainly two options here. You can either raise the plants in a lab or in a mesocosm type of system, in which case you don't have to worry about the donor material or damaging any beds because you're raising them in a lab. So you are ready to transplant in that case. Alternatively, if you plan to harvest from a donor meadow for your restoration project, there are a few things you need to consider. The first thing you need to consider above all else is to minimize damage to the donor meadow. So there's a few ways in which you can do this. We recommend that you harvest your eelgrass on scuba or by snorkel. This is preferred over walking over a meadow or wading through it, because you're creating a lot of damage when you do that and inadvertently pulling up a lot of the eelgrass. And when you're doing that, what we do in places like Elkhorn Slough is we do this approach where we are on scuba, we harvest one shoot, put that one shoot into our mesh bag, kick, 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 grab another shoot, put it into our mesh bag, kick, 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 and do that across the meadow. There's two benefits to doing it this way. The first is that you're minimizing the disturbance to the donor meadow by not creating any bare patches. The second thing is you're actually having a better chance of increasing the genetic diversity of the harvested shoots by harvesting over a larger area. So the other thing to consider is that when you're harvesting from a donor meadow, the standard recommendation is to not remove more than 10% of the donor meadow eelgrass. And so that's something that we also recommend doing. The third thing that we recommend is when you're harvesting the eelgrass, you want to make sure that you're not harvesting more than ideally you can transplant in a single day. You want to make sure that your shoots are always stored in a cooler with fresh seawater, because this will minimize stress to the plants. You also want to minimize the time that those plants stay in the cooler. And so the best way to manage this is by only harvesting what you think you can manage to transplant in a single day, so that you're not keeping the shoots overnight. But they can stay in a cooler comfortably for 12 to 24 hours if you absolutely need to.
So assuming you've determined what site is best suitable for your restoration project and you've acquired your transplant material, you're now ready to choose a restoration method. So there are multiple restoration methods that have been used successfully. For example, popsicle stick methods or bamboo stake methods, rebar methods, buoy deploy seeding or buds methods, turfs, transplanting eelgrass remotely with frames, or passive methods where you're restoring the natural hydrology or sediment such that eelgrass can return on its own. All of those methods have their own pros and cons, and we discuss a lot of those different methods in the videos to follow this episode. So the best thing to do is just to consider carefully your project's needs and walk through those pros and cons of different methods. So for example, some projects might be cheaper than others, some might use more durable materials, while others might have biodegradable materials. Some lend themselves well to community involvement, others require more advanced involvement with scuba divers, and each of those might dictate what method you choose. All of them can be successful, although some have been more successful than others and are going to be based on project-specific needs.
After you've chosen your method, you now get to begin doing some of the planting. However, given the high likelihood of restoration failure, it's important to start by doing test or pilot transplanting. And this is a really great opportunity to transplant using multiple methods and using different arrays to understand what the best method is for your specific project constraints and site. You can also learn a lot about a site's eelgrass success and growth patterns by transplanting in different areas within a site. So for your pilot restoration, what a lot of folks do is they'll actually plant with a different configuration, so that, for example, in an L shape, so they can transplant using different methods, potentially along an elevation or depth gradient, And then they can also look at different hydrodynamic regimes by orienting the planting arrays in different directions. And so that's a good way to best understand how to place your transplants in a way that improves the restoration outcomes by incorporating site specifics. So after monitoring these pilot projects for success, ideally for up to a year, you're able to do full-scale restoration with the knowledge you gained from the pilot. So we discussed the mechanics of specific transplanting methods in our other videos, so we're going to skip that for now and take that time to discuss monitoring, which is a key component of restoration projects that we don't want to ever overlook. So when developing your restoration project, you should also write up a monitoring plan. And in that monitoring plan, you need to discuss how you're going to define success, how you're going to measure that success, how long you're going to monitor for, and if funding permits, you want to also include as many ecosystem functions that you're monitoring concurrently with your restoration project as is possible. So at a bare minimum, what we recommend is measuring shoot density, aerial coverage, and percent cover, because these are the most commonly used metrics when evaluating eelgrass restoration success. Regardless of what you choose to measure though, it's really important that you get good baseline data. And what that means is ideally you're collecting data on both structural and functional metrics before or immediately after transplanting. And if you can also monitor funding permitted and time permitting, if you can also monitor the natural meadows, that's really important for making sure that the restoration project is on a trajectory where it is tracking the performance of the natural meadows, because that's really the mark that you want to strive for with your restoration project.
In sum, a well-planned restoration project is going to be a more successful restoration project. So we've gone through all of the steps, which are first, to conduct a site suitability analysis. Second, select your methods. Third, conduct a pilot restoration. Fourth, conduct your restoration at scale. And fifth, monitor your restoration efforts. So if you follow these 5 steps, you're much more likely to have a successful restoration project. We also hope that as restoration is conducted, practitioners share the results and reports from that restoration so we can get a better understanding of our successes and failures across the region. We hope that this video series can help all of the practitioners to better design and implement their restoration projects, and best of luck with the restoration.